if we look at section 1-5 equations, we know that an open sentence is a mathematical sentence with one or more variables. And we know that a true sentence is a mathematical relationship that is correct or equal. Open sentences are solved by finding replacements for variables that result in true sentences. And we solve these open sentences by finding values that make the statement true. So when we have an equation, we can have what is called a replacement set. And a replacement set is a set of numbers that we replace for a variable. Oftentimes you will see them organized in a table. We know that the solution set is the set of all replacements for the variable that give a true statement. So I can put anything into the equation that I want, but my solutions are the only ones that make it true. And we call that an equation. And we know that an equation is a sentence that contains an equal sign. When I have an expression, I can replace that expression with multiple numbers. But when I have an equal sign, that limits the number of answers I have that are correct. So again, that limits the number of answers that I have that are correct. Oftentimes, this is easier to see in examples. So the directions tell me to find the solution of each equation if the replacement set is A equal to 4, 5, 6, 7, 8, and then write the solution set. So when I am given a replacement set, I have to substitute every one of those values for A. I don't just pick and choose, and I don't just find the correct one. When I am given a replacement set, I have to replace the variable for every one of the numbers in this set. So what that looks like is as follows. I am going to write my equation and instead of A, I am going to use the first value in my replacement set. I'm going to replace the A with the 4, and then I'm going to solve it. 5 times 4 is 20. 20 minus 9 is 11. Well, I can see that 26 is not equal to 11, so 4 is not a solution. And then I am going to repeat the process for the next number in the replacement set, which in this case is 5. And I'm going to solve it again. 5 times 5 is 25. 25 minus 9 is 16. 26 is not equal to 16, so 5 is not a solution. I am going to continue for the next number in my replacement set. I did 4, I did 5, now I am going to substitute 6 because that is the next number in my replacement set. 5 times 6 is 30, 30 minus 9 is 21, these do not match, therefore 6 is not a solution. And because my replacement set still has numbers, I keep going. If you have done this in your head and you've gotten to the correct answer, you've gotten to the solution, that's great, but you must keep going. My next number in my solution set is 7. 5 times 7 is 35. 35 minus 9 is 26. My equations match, therefore 7 is a solution to my equation. But I do not stop when I get to a solution. I must keep going, and I must substitute every single number in my replacement set. The next number is 8. 5 times 8 is 40. 40 minus 9 is 31. That doesn't work. The only number that will fit into my solution set is 7. And you make your brackets as fancy as you can. Doesn't have to be perfect. But in this case, the solution set is 7. The replacement set contains all of the numbers, and your solution set only contains the numbers that make your equation true. This is different than just simply trying to solve for A. These are the steps that you must follow to get credit for this assignment. So in this case, we have another example. 4a minus 8 is equal to 16, and we are going to use the same replacement set. So I have 4, everywhere I see a, I'm going to put parentheses. The first a, again, we know is 4. 4 times 4 is 16. 16 minus 8 is 8. So we know that that is not a solution set. I repeat my steps again for the next number in my replacement set, 5. 4 times 5 is 20. 20 minus 8 is 12. 16 and 12 are not equal, so 5 is not a solution. And I have to write this equation for as many numbers as are in my replacement set. My next number is 6. 4 times 6 is 24. 24 minus 8 is 16. That is a solution. I do not stop because there could be other solutions. I keep going, and I must have an equation for every number in my replacement set. 4 times 7 is 28. 28 minus 8 is 20. That is not a solution. The last number in my replacement set is 8. Four times 8 is 32. Minus 8 is 24. This is not a solution, but I did get one correct answer, so therefore I make my brackets. I write my solution set, and my solution set are what makes my equation true. In this equation, 6 is my only solution based on my replacement set, and in this equation, 7 is. And this is how I write my answer for solution sets. You could also be asked to solve equations that look like this. And in these equations, all the variables are by themselves. So these are very basic equations, so I am just going to use my order of operations because the variable is already by itself. 10.4 minus 6.8 is 3.6, and that is equal to x, and then I circle my answer. Because I don't have a replacement set, I don't have to keep going. It just asks me to find what x is. Here it's going to ask me what a is. I simply solve the numerator and then the denominator. 46 minus 15 is 31. 3 plus 28 is 31. 31 over 31 lets me know that 1 is equal to a. In this example, I'm just going to subtract 20.1 minus 11.9 gives me 8.2, and therefore y is equal to 8.2. And in number 6, it's another fraction, so I do the numerator and then I do the denominator. 6 plus 18 is 24. 31 minus 25 is 6. And 24 over 6 is just division, so I say 24 divided by 6, which is 4, and that is my value for C. We can also use equations to find the answers to word problems. So Miss Raz has 15 weeks in which to teach 6 chapters. Write and then solve an equation that represents the number of lessons the teacher must teach per week if there are an average of 8.5 lessons per chapter. So the first thing we want to do is examine what is the information that is here. So we know that Ms. Raz has 15 weeks to do 6 chapters. And we know that there are an average of 8.5 lessons per chapter. So what we want to find out is the number of lessons the teacher must teach per week. And we know that there are 15 weeks. So we know whatever we get, we're going to be dividing by 15 weeks to see the number of lessons that the teacher must teach. And if we know that there are 6 chapters and there are 8.5 lessons per chapter, I would take 6 times 8.5 to get the total number of lessons. And we know that the teacher needs to teach, we know that Miss Raz needs to teach that in 15 weeks. So now we just simplify. 6 times 8.5 is 51. And 51 divided by 15 is 3.4. And therefore we know that the teacher must teach, that Miss Raz must teach 3.4 lessons per week. And the reason that we write our answer in full sentences is because this is a word problem. So let's look at another example here. Mrs. O'Brien purchases an inflatable kayak weighing 30 pounds from an online company. The standard rate to ship this purchase is $2.99 plus 85 cents per pound. Write and solve an equation to find the total amount Mrs. O'Brien will pay to have the kayak shipped to her home. So we are looking for shipping. We could reduce that to the variable s, but we're just going to call it shipping. And we have to use the information in the equation to find it. So we know that the kayak is 30 pounds. And we know that shipping has a flat rate of $2.99 plus 85 cents per pound. So we want to write and solve an equation. So my equation is going to be that shipping is equal to that flat rate of $2.99. That means everybody pays that, plus 85 cents times how many pounds the kayak is. And the kayak is 30 pounds. So that's what I'm replacing it with. And now I know that I simplify the problem. 85 cents times 30 pounds is $25.50. And when I add my $2.99 for my flat rate of shipping, I get that Mrs. O'Brien will pay $28.49 for shipping. But because this is a word problem, I need to write my answer as a sentence. So I would say that Mrs. O'Brien will pay $28.49 to ship her kayak. So these are just some examples of how equations will be used in our class. Make sure that if you have any questions, you bring them to Mrs. O'Brien and myself.